Hey coding bots. So basically in today's GFG POTD we have a problem, size of binary tree, and it is a basic level of problem, and as the problem statement is given the root of binary tree, return the size of the tree. The size of binary tree is the total number of nodes in the tree. So here in the game problems, here we have binary tree. We know very well about binary trees. Those trees which have at most two children, like either 0, 1 or 2, are considered to be like binary tree. But here we have just simply done the size or the length of the tree. Okay, like here we can say that in the example one, here we have like 1 2 3. So here to just return the total size of binary tree. Okay, so after like counting this number, we're actually getting 1, then 2, then 3. So here output will like 3. So here explanation is like also given, that means there are 3 nodes in the given binary tree, so its size is like 3. Similarly, if I'm talking about the second example here, so here we have like 5, then 1, then 6, then 3, 7, 4. So after counting it, we're actually getting, let's say, 1, then 2, then 3, then 4, 5, and then 6. So here we can say that there are 6 nodes in the given binary tree, so its size is 6. So basically in the given problem, here you just simply calculate the total number of nodes in the given binary tree. So how we can do those things? Now we know very well how we have to traverse inside the trees, okay, and how we can calculate its total length or the total size for the given nodes inside the binary tree. So these are like really very much basic problem. We can easily able to return its total size for the nodes, but before that we would like to read about constant. So here constant is like number of nodes should be like greater than equal to 1 and less than or equal to 10 to the power 5, and node data should be like greater than equal to 1 and less than or equal to 10 to the power 5. And here we need to solve this problem with an expected time complexity of order of n, and expected auxiliary space is like order of h. Okay, and this is completely based on trees and data structures. Okay, that means here we have to just perform only one thing, which is like finding the total length of the nodes. Okay, and here rated articles is like also there, like write a C program to calculate size of a tree. Okay, so what is our approach to solve the given problem here? See, while solving these kind of problems, let's say for trees or any kind of like the English type, so in that case we must have to define about the base case. That means, let's say if the tree is like not available, or let's say if the tree is having length of 0, so in that case we have to give the base case. Okay, so what I can do here, I can just simply check if the root is equal to null. In that case we have to simply return 0. Okay, as it is of as our function is of integer type, so it will return the integer value. So here we have to just simply return 0. Now after that we need to find the size of the node for the binary tree. Okay, so we can solve it within the one line by using recursion. We know what about recursion. When a function is calling itself again and again, then it is called as recursion. And here our recursive function is like get size is of functions by which we can easily to get the total size or length of the given binary tree. So here what we can do here is to just simply return. Now we know whether if the length is like 0, in that case we have to simply return 0, but if it contains at least one node also, then we have to return 1. So in that case what we will do, let's say if this binary tree is having only one node, so in that case we have to return 1. But let's here it is like not 1. If it is like 1, then in that case we have to just simply return 1. But here we have also like 2 and 3. So in that case what we will do, for getting 2, that means from the left side we need to traverse through to the left node. Okay, and how we can move towards the left node? See, here we can perform the recursive operations like get size, which is already defined here, and inside the get size we have a parameter like node rows. So here we can just simply define our node is like we can say that root. Okay, here our node is like root, and then we can just simply put the value as left. Okay, and then we can just simply add again get size if it is having the right node also. So So here we can just, our node is like root, and we have to move towards root right side. Okay, so if I like performing those things, we actually getting the total length. Like one is by default if it is having at least one node. Okay, if it is having 0, then in that case we have to return 0. But if it is having at least one node also, so in that case it will return 1, and these functions will not return any value, so in that case we will return 1. But if it is having the left node also as well as right node also, then it will again it will calculate the total length also. So let's try to compile and run. Yeah, here compilation is completed, and it's these functions basically returns the length values. Okay, like roots dot length. So in that case, let's say 1 plus roots dot size. Okay, roots left side, so it will basically calculate this, then again plus roots right, then it basically moves towards this, so it's basically calculates the total number or total size of the length of the binary tree. So let's try to compile and run. So yeah, its compilation is completed, and I've also submitted it. So that's all for today. Thanks for watching.